Today I'm here to explain about this question. It looks so complicated, but actually it's pretty similar to transformation of graphs. Do you remember that? If you understand this one, you can easily solve this question. But there are some new terms for you like amplitude, period, and phase shift. So let me explain about it today. First, let's work on amplitude. What is amplitude? Let me sketch the graph for y equals sine x. And do you know what does it look like? So what I'll do to sketch the graph, I plot 5 points when x equals 0, when x is equal to pi over 2, pi, 3 pi over 2, and 2 pi. When x equals 0, sine 0 is 0. Sine pi over 2 is 1. Sine pi 0. Sine 3 pi over 2 is negative 1. Sine 2 pi is 0. So dots are like that. Then you can connect them smoothly, like this. Oops. This is sine graph. Then where is amplitude in this graph? Actually, it's here. Amplitude is how much the graph sway away from the middle position. Middle position is here, x-axis, and how much it sways away. So this red line, the length of red line is amplitude. And in other words, it is half of difference between maximum and minimum. So half of this. So actually anyway it would be okay here or here. Anyway, this is amplitude. So when x equals sine x, amplitude is 1. What was sine 2? So the y equals 2 sine x. Let me sketch the graph of it. It's here. Oops. The graph is going to be like that. So when x equals 2 sine x, amplitude is going to be 2. So what I wanted to say is amplitude totally depends on the value, depends on the coefficient here. So if the function is like this, y equals a sine x, amplitude is going to be absolute value of a, because it shows the length. So even though like y equals negative sine x, it's going to be 1. So it's absolute value of a. So in this question, it's here. So amplitude is 2 in this question. Okay. Okay, next let me explain about period. Again, I sketched the graph of y equals sine x here. What is period then? Period is the length of small interval that contains exactly one copy of repeating patterns. Let me start it here. You can start from anywhere, but actually this graph has this one. so many times. It will continue like endlessly. This small interval and the length of this small interval, I mean here or here, it's called period. Let me calculate it. This one is from 0 to 2 pi, so the period of y equals sine x is 2 pi. That's the period. So let's compare. Let's find another graph, y equals sine 2x. What's the period of this graph? Y equals sine x is going to be, so let me see, but it's going to be like that. So small interval, it's here, this one. Maybe it's better to change the color. So let me use purple. So this is one small interval from here to here. In this case, the period is pi. What's the difference? So let me conclude it. If you have the graph y equals sine ax, then period is going to 2. Okay, let me use another word, bx. The period is going to be 2 pi over the absolute value of b. And in this function y equals sine 2x, the value of b is 2. This means 2 pi over 2 is equivalent to pi. So the period of this function is pi. And also the question here, the value of b is also 2. So the period of this function is also pi. Okay. And next, let's work on phase shift. I've already sketched the graph for y equals sine x like before. And let me sketch another graph, which is y equals sine x negative pi over 6. How does the graph look like? Looks like the graph is going to be like that. So actually, it looks like the graph shifts this way. It's called phase shift. And how many it shifts depends on this value. So in this case, x negative pi over 6. In this case, it shifts right pi over 6. This is how it works. So if the function have y equals sine x negative, let's say c, it means graph shift right. Graph shift c right. Okay. If the value is positive, it goes left. If the value is negative, it goes right. That's a phase shift. It's same as the transformation of graph. Then lastly, finally, vertical displacement. And again, I've already put the graph, sketch the graph y equals sine x. And let me sketch the graph of y equals sine x plus 3. But we can take a guess how does the graph look like. Okay, let me change the body here. Let me change it 1. So the graph is going to be like this. this way goes here, and this like that. So this means this looks so ugly, but it goes shift up, goes shift 1 up. It depends on the value here. So if it's positive, it's shift up. If it's negative, shift down. So if you have the function y equals sine x plus, let's say, plus d, this means we shift d up. Okay. So finally, let me conclude it. If you have the function f of x equal a sine b times x negative c plus d, or it can be 2 of cosine, amplitude is the same as here. It's going to be absolute value of a, and period, let me change the color, it will be affected by this value b. It's going to be 2 pi over absolute value of v. And next, phase shift, it depends on this value here. So if it's negative c, it's going to be c. Let's shift c right. So if this value is positive, it goes left. And finally, vertical placement, it depends on the value here. So shift d up. If the value is negative, it's shift down. So let's work on one more question to use this. So let's say y equal negative 3 cosine to x plus pi over 2 plus 3. In this case, amplitude is the absolute value of here, so which is 3, and period depends on the value here, so it's going to be 2 pi over 2, which is pi. And phase shift comes from here, so it's going to be negative pi over 2. And finally, vertical displacement comes from here, which is 3 upward.